The topic of this lecture is Permutation and Combination Part 1. We will cover these points in this lecture: permutation and combination, important facts, and some solved examples. So these 3 points we are going to cover. So first we start with the definition of factorial n. What does it mean by factorial n? Let n be a positive integer. Positive integer means n can be 1, 2, 3, and so on. So this is n. Then factorial n is denoted by this symbol or by this symbol. So this is the notation of factorial n, and defined by factorial n is equal to n into n minus 1 into n minus 2 into n minus 3 up to 4, 3, 2, 1. For example, to understand this, what is the factorial 4? Factorial 4 will be n is equal to 4 here. So first is 4, then 1 less, that is 3, then less 2, then less 1. So this is factorial 4, which is given over here. This is factorial 4. Similarly, what is factorial 5? Factorial 5 will be, so n is equal to 5 here. So starting with 5, then 4, then 3, then 2, then 1. And when we will multiply all these numbers, we will get the answer 120, which is written over here. Also, we defined factorial 0, that is, or by this notation, its value is 1. So this you keep in mind. And factorial 1, of course, factorial 1's value will be 1. So all these four things I have described over here. Now let us see what is meant by permutation. Permutation, the different arrangement of a given number of things by taking some or all at a time are called the permutation. Means suppose if you are given the 3 items and you have to take 2 out of them and you have to arrange, then what will be the number of arrangements? That is called the permutation. So let us see this by example. All permutations or arrangement made of the letter ABC. So here 3 letters are given, ABC, taking 2 at a time. So out of 3 we have to take 2 at a time are given by, so what will be the arrangements? You are given ABC and you have to take only 2. So you can take AB, then you can take BA because we are arranging. So by this way also, then BC, then CB, then AC and CA. So total 6 arrangement will be there. So it is written over here. Now if we take the 3 letters against A, B, C, and all this we have to arrange, taking all the 3 letters at a time. So what will be the arrangement? So arrangement will be A, B, C, then A, C, B. So this is second arrangement. Then you can start with B, A, C and B, C, A, then C, A, B and C, B, A. So again here there will be 6 different arrangements. So that is the permutation. Now let us see the definition of number of permutation of n things taking r at a time. Means there are total n objects and out of this we have to take r object. So how many possible arrangements will be there? So that is denoted by NPR. And its definition is n minus 1, n minus 2 up to n minus r plus 1. And that will be same as factorial n upon factorial n minus r. So let us understand this by an example. Let us take n is equal to 3 and r is equal to 2. And we know in this case total arrangement should be 6. We have seen in this example. So let us see this with formula. So formula says here n is equal to 3. So it is factorial 3 divided by 3 minus 2 factorial. So this will be factorial 3 means 3 into 2 into 1 divided by 3 minus 2 means factorial 1. Factorial 1 means 1. So this will be 3 into 2 is equal to 6. So we are getting the answer. So by this way you can use this formula to find the values. Or one simple way is, whenever you have to find, suppose NP2 and P2. So in place of using this formula, what you can do, you write two factors starting with n into n minus 1. So that will be easy. NP3, so starting with n into n minus 1 into n minus 2. You write three factors. Okay, like this way, using this, let us see one example. 8p2. What is the value of 8p2? 8p2. So two factors we have to write starting with 8. So 8 into 7, that is 56. Then let us say 7p3. So three factors we have to write starting with 7. So 7 into 6 into 5, and that will be total as 210, which is written over here. So like this way you can calculate. Now let us see some more facts. So number of all permutation of n things taking all at a time is factorial n. If you are given n is equal to same as r, that is we have to find the value of npn. So its value will be factorial n. So this is the first fact. Now second is also important. If there are n objects of, suppose n objects are there, and p1 are of one time, p2 are of one time, and similarly pr of the one type, it means the sum of all this dot dot, if it is equal to n, then in this case number of permutations will be factorial n upon factorial p1, factorial p2, factorial pr. So this will be the formula in this case. For example, if you are given the word a, b, c, a, d, so you can see there are 1, 2, 3, 4, 5 words are there, and we have to arrange 5 words. And here you just see a is repeated 2 times, b is 1 time, c is 1 time, and d is 1 time. So according to this formula, this will be the total arrangements will be factorial 5 divided by factorial 2, because a is repeated 2 times, d is repeated 1, b and c are repeated 1 times. So factorial 2 into factorial 1 into factorial 1 into factorial 1. So it will be simply factorial 5. Factorial 5 means 5 into 4 into 3 into 2 into 1 divided by factorial 2. Factorial 2 into 2 into 1, and all our values having 1, 1, 1. So 2 and 2 cancel, and you have to multiply this 5 into 4 into 3. So total will be the 60. So this will be the total arrangements in this case. Now what is meant by combination? Combination means each of the different groups of selection which can be formed by taking some or all at a time is called the combination. For example, if there are 3 boys A, B, C and we want to select 2. So what will be the selection? Here we are not going to arrange, we are selecting them. So we are having the 3 persons or 3 boys A, B, C, and we have to select 2 only. So A, B, that will be the first, second may be B, C, and third will be C, A. So these are the only selection, 3 selections will be there. You cannot take A, B and B, A, because this is the same selection. So this 2 will be same. So here we are not going to consider B, A if we are considering A, B. So only there will be 3 selections. Similarly, if we are having 3 letters A, B, C, and we have to take all at a time, so only the 1 selection will be there. And if we are having, suppose, the 4 letters A, B, C, D, and we have to take only 2 out of them. So selection will be AB or AC or AD or BC, BD and CD. Here again, as I told you, AB and BA are two different permutation, but they represent the same combination. Arrangement is different, but selection is same. Now what is the formula in this case? The formula says this you can find by using formula NCR, which is given by factorial n divided by factorial r into n minus r. So this will be the formula in this case. Okay, so this formula we are going to use when we find the combination. Now let us see some facts here. NCN, that you keep in the mind, that will be always 1. NC0, that will be also 1. So this 2's value always is equal to 1. NCR, that will be same as NCN minus R. For example, 16C3, 13. That will be same as 16C. 16 minus 13 means 16 minus 13, that is 16C3, and its value will be 16 into 15 into 14, 3 times, and divided by factorial 3. So 3 into 2 into 1. So using this you can find the value of the combination. Here also just see 8C3 we have to calculate, 8C3. So here you will have to write 8, 3 factors, 8, then 7, then 6, and divide by factorial 3. So 3 into 2 into 1. Note that if in case of permutation 8p3, we write here 8 into 7 into 6. And in case of combination, we will have to divide by factorial 3 also. So let us quickly see this formula once again. This was the formula, and here you can calculate in place of this. You can write the factors n, n minus 1, n minus 2 up to r factors, and divide by factorial r. So this formula we have used here. Which formula we have used? That 8C3 we have written as 8C3. Let us quickly this one see once again. 8 into 7 into 6 divide by factorial 3. So factorial 3, which is written over here. So we have to evaluate, suppose 50, factorial 50 upon factorial 48. So factorial 50 divide by factorial 48. So simply this can be written as 50 into 49 into 48 factorial divide by 48 factorial. So this 2 will be cancelled, and only 50 into 49, that is the answer 2450. This will be the answer in this case. Now evaluate 5P5 and 50P3. So 5P5 will be simply factorial 5 and its value is 120. 50P3, how will you evaluate? That will be factorial 50 divided by 50 minus 3 factorial. So factorial 50 upon factorial 47. So let us see once again, so you will understand how we are calculating factorial 50 divided by factorial 47. So it is very simple. You write down 50 into 49 into 48, and remaining is factorial 47 divided by factorial 47. So this 2 will be cancelled, and remaining will be 50 into 40 into 49 into 48. So this will be the answer. Similarly, the combination tan C3. So tan C3, as I told you, how will you evaluate this? You can evaluate by writing 10 into 9 into 8 divided by factorial 3. So that is 10 into 9 into 8 divided by factorial 3 means 3 into 2 into 1. So whatever the answer will be, here answer is 120. So you can evaluate this by multiplying this and divide by this. Similarly, 100C98. Again you see 100C98. This will be simplified as 100 minus 98. So it is 2. So this will be simply 100 into one more factor, that is 99, divided by factorial 2, that is 2 into 1. So the answer will be 4950. So this will be the answer in this case. Now let us quickly see this example. In how many different ways can the letter word fight be arranged? So how many words are there? Here are 5 and all are different words. So this can be arranged by factorial 5 ways, that is 120 ways. Now in second example, in how many ways, different ways can the letter of the word preset be arranged? Here you can see there are total 7 words. And here the E is repeated 2 times. And all 5 are different words. So what you can do? So the answer will be by using our formula factorial 7 divided by E is repeated 2 times, so factorial 2 into all are repeated 1 time. So factorial 1 into factorial 1 into factorial 1 into factorial 1 into factorial 1. But here you can see only factorial 7 upon factorial 2 is written. Why? Because all this factorial 1 are having the value 1. So no need to write these values. Let us see one more example. In how many arrangements can be made out of the letter engineering? So here you can see there are total 11 letters. These are the 11 letters. And E is repeated 3 times. You can see N is repeated 3 times. G is repeated 2 times. I is repeated 2 times. And R is repeated 1 time. So what we'll do? So factorial 11 divide by factorial 3 for this E into factorial N. So factorial 3 for G, factorial 2, I is repeated 2 times, so factorial 2, and R is repeated factorial 1 times. Here need not to write factorial 1 because its answer will be 1. So this will be the case. And here factorial 11. So factorial 11 means 11 into 10 into 9 into 8 and all these things up to 2. And here factorial 3 means factorial 3's value will be, always 3 into 2 into 1. That is 6. So here only values are written and you just calculate using the calculator. So you will find this answer very easy. Now let us quickly see these two examples which are important. In how many different ways can the letter word DESIGN be arranged so that the vowels are at the two end? So you can see there are 6 letters, 1, 2, 3, 4, 5 and 6. So at the end points, at the end vowel should be there, and vowels here are E and I. So these two vowels at these two places, this can be arranged by factorial 2 ways because 2 letters are there. So this is factorial 2. Now remaining 1, 2, 3, 4, these are the consonants, and these can be arranged by, because there are 4, so these can be arranged by factorial 4 ways. So vowels can be arranged by factorial 2 ways, consonant can be arranged by factorial 4 ways. So total number of ways will be factorial 2 into factorial 4. So when you solve this, you will get the answer which is written as a 48. So what was the problem? Vowel should be at the end. So we will place these two vowels over here. That can be arranged by factorial 2 ways. Consonant, there are 1, 2, 3, 4 can be arranged by factorial 4 ways. So total number of ways will be factorial 2 into factorial 4, which is written over here, which is solved over here. Similarly, in how many ways the word D, A, U, G, H, T, R can be arranged so that vowels always comes together. So how many vowels are there? Here are three vowels, A, U and E. This will consider at present as a one letter. So all these letters, eight letters, will write. Let us see in this fashion: the D, G, H, T, R, and A, U, V. So now it becomes the six letters. One, two, three, four, five. This five, and we are treating this as a single letter. So this six letter. Now these six letters can be arranged by factorial six ways. So this is the first thing. Now this A, U, E, these vowels, there are three vowels A, U, E, and these can be arranged by factorial three ways. So it is answer is 6. So the total answer will be 720 into 6, that is 4320. So that will be the answer. Let us see what we did once again. We have written all vowels together and all consonant over here. So total these words, because treating this as a one letter, so total these are six letters. This can be arranged by factorial six ways. And remaining this 3, 1, 2, 3 vowels can be arranged by factorial three ways. So total number of ways will be factorial 6 into factorial 3, that is 720 into 6, that is 4320. So by this way, these two problems we have solved, and it is very easy. So this Beamer presentation, if you want, you can download from the link which is given in the description. Thank you very much.